So guys, my name is Tomasz. I'm working as a solution architect at AWS, Amazon Web Services. And as you can expect, we will be talking about AWS, Amazon Web Services, and about the cloud. So the topic of this presentation is about how companies are using the cloud to build application systems faster. And the most popular approaches currently is serverless and containers. So we will focus on this session. I thought I have got 1 hour. It turned out that I have got 1 hour 15 minutes. So during the break, I have added a couple of more demo. So I'm pretty sure I will regret it because it won't work. But let's see. Okay, guys, so innovation. Innovation is something really important currently because, in short, we want to build application systems which don't exist yet to be the first on the market. And if we would think about the Amazon, of course, a lot of people still think, Amazon, yeah, so this is the shop, an online shop, a place where we can buy books, everything. But currently, this innovation is changing also the Amazon. So Amazon is doing a lot of different things. So of course, Amazon Prime Air, so to try to deliver, things which you buy on Amazon, not by truck, by drone. Another case, Amazon Go. So a new kind of shop where we can go when we just can pick up something from the shelf and we can just leave the place without paying, without standing in the line. Of course, Alexa. We will hear a lot about Alexa today. There are some Alexa on the second floor, so you can try to talk with it and try to communicate with your application systems using, your voice. But for me, especially, the most important is this. So this will be AWS. So about 10 years ago, the idea in Amazon was, okay, let's provide the technology which we are doing to the third-party companies. Let's provide them this functionality so they could use it to build their application, their systems faster. So, and this is AWS. And now there's, millions of companies around the world which are using the cloud to build their application. So who of you are using Netflix? Okay, so if you are using Netflix, you are using AWS because the whole Netflix is running on AWS. If you ever play Angry Birds, you are using AWS. And this is a really interesting story about the innovation because the company which created Angry Birds, I think the name was Rovio, has created about, 40, 50, 60 games before this game, which, it wasn't success. But then suddenly they created Angry Birds and suddenly everybody started playing it. So this was a great success, and because they were on the cloud, so they were able to provide this game to everybody. Tinder. Julian already mentioned this, but let's check. Who is using Tinder? Be honest. Yeah, of course, yeah. Tinder, what? Yeah. We don't have it in Poland. Yeah, guys, so let's imagine that you're using Tinder, and this is an application where you're just swiping left, right, and you're looking for your true love. And when you will find this true love, the truth is that the cloud, artificial intelligence, is helping you. So underneath the Tinder is using SageMaker, so the functionality which we saw in the previous session. So SageMaker is being used to provide you the next person, and this person should be the best person for you. So if you will find somebody, think that this is thanks to artificial intelligence. So Airbnb, the company which completely revolutionized the way how we travel. So probably we won't try to book a hotel, we'll find, a private house, a private home, which is just cheaper. Pinterest, just publish some art, some things which we draw. A lot of companies from the financial companies. Enterprises, but also startups. So currently, 100% of the fintech 50, so the most popular, the biggest fintech from Forbes list, are using AWS. So if you are buying or selling cryptocurrency on Coinbase, you are using AWS. An example, Monzo. I guess you don't know Monzo. Monzo is a startup from UK. This is a startup which didn't exist 3 years ago. Now it's a startup, fully regulated bank in UK with about 500,000 of users in UK. This is a bank which didn't exist 3 years ago, and now it's operating in UK. So we see that the cloud is providing those functionalities so the companies can be more faster and they can build their application system just better. So this is a quote about the fintech, but I think it's, we can use it everywhere. So banks aren't being disrupted by fintech technology, they are being disrupted by the customer expectations. So the thing about the fintech, the startups, is that they can build their application systems really fast. So when they see that the customer needs something, or when they feel that they need something, it will take them days, maybe weeks, maybe months, but then they will provide it to their end customers. So this is, the possibility of building applications quite fast. But we need to build something, okay? So if we would look how we used to build application systems around 10 years ago, we would see that we were using this monolithical approach. Very often this whole application was lying on a single server, maybe a couple of servers, and we were using really heavy technology to communicate them, like SOAP and so on. Suddenly, we started breaking those applications into smaller pieces. So we started calling those microservices. We started using technologies like REST, like JSON. And it just became easier to break those into those smaller pieces. So those are now the microservices. This is the place where we store the business logic. So now this is our application. So there's a lot of interactions between those microservices. And when we are extending the application with new functionalities, we are just adding new blocks, new microservices. So when we are using microservices in the cloud, we can do this in the same way. So we have got our business logic, which is being built on servers, on containers, or maybe something else. But we also are using things which are already provided by the cloud. So we don't want to do everything by ourselves because we want to focus on the business. We want to quickly provide something to our end users. So, like I said, this topic will be focusing on two things, serverless and containers. Containers will be a bit shorter, serverless will be the main point here. So those microservices, suddenly we started breaking into smaller pieces, which we call sometimes still microservices, sometimes we call it nanoservices, sometimes we will call it function. So now whenever there is, for example, the invocation from outside, for example, from Amazon API gateway, so REST API, so those functions will just wake up, they will do what we have implemented there, and then they will fall asleep again. So when they are not doing anything, in short, we don't want to pay for anything. And we can really focus on the business logic, not on the infrastructure. So, but let's do a step back. So if we look at the cloud, the cloud. Some people believe that the cloud is just, a fancy word for a data center, which is operated by a third-party company. It's somewhere, but still it's just a data center. The cloud will be this, which I showed you at the beginning. So those are Lego blocks. So we are going to the cloud to choose those Lego blocks, those functionalities, thanks to which we'll build something faster, better than we would do in a real life, in old life. Let's say it like this. So, of course, there will be a Lego block, a functionality, which is a server. And we can go to the cloud, we can spin up a server or maybe thousands of them, and we can build an application. It will work, it's okay. But the question is, maybe there is a better, maybe there is an easier way. Just forget about the servers and just focus on the business logic, on what we want to implement. So there's a lot of different Lego blocks. So maybe we want to do some kind of big data analysis, and we need a Hadoop ecosystem. We could spin up a server, or we could use a Lego block which is providing Hadoop ecosystem. Maybe we need to have a database. Probably we need to have a database, so we could do everything by ourselves, or we could just say to AWS, yeah, I need to have a database. Maybe MySQL, maybe Oracle, something. And then in 10 minutes we have got a database, but we don't need to manage this. We can really focus more on the business logic, which is, this is something on which we should focus. So, and then, our application will be a bit different. So another way of looking at the cloud is something like this. So the cloud is providing the cloud services. So those are those Lego blocks, those functionalities. And there are services like EC2. EC2 will be a server in the cloud. But after a while, people started saying, yeah, I want to use the cloud, but I don't want to think about the infrastructure, about the servers, and so on. So inside of this group, there is something which is called the managed services. So there is, for example, something which is called RDS, which is managed database, which is managed by AWS. So we are saying, yes, I need to have a MySQL database, but I don't want to manage this. It should be managed by the cloud. And then the user see the server, but he doesn't have access to it. He don't need to install it, he don't need to patch it, and so on, because it will be done by AWS, by the cloud provider. But then the people started saying, yeah, but here I still see the server. I don't have access to it, but I see it. So I don't want to do it. I don't want to think about the infrastructure at all. So inside of this group, there is serverless services. So now we are saying, this is my application, dear cloud, run it, deploy it somewhere. I don't want to think about the infrastructure. So this is one level higher. So this serverless approach is really important, especially for startups. Because, let's imagine that we are building something. There is, of course, development phase. We are, coding and so on. And then we end the coding. We are finished. We are done. We would like to, show it to the world, but we can't because, there is a boring stuff which needs to be done. Where we will deploy it? Who will be managing this? And so on. Then finally, we answer this, go live. We are happy. We would like to build new things, but we can't because there is even more boring stuff. Still, somebody needs to manage this infrastructure. Still, once time every month, somebody will need to access the server, patch the Windows, Linux, and so on. So maybe it would be just better to focus just on the development, and this is the serverless approach. So this is the quote of the CTO of Amazon, who once said that no server is easier to manage than no server, because we want to focus on the business, on the logic which we are writing, not on the infrastructure. So there is this service which is called a Lambda, which I already showed you a couple of slides before, which is this microservice, which is this nano service, a function, but without a server. So the point here is that we are taking our application, our business logic, a piece of code which we wrote in a couple of different languages, Java, Python, Node.js. We are throwing it to the cloud and we are saying, dear cloud, manage this. Do everything because this should work. And my role is just to write this business logic and then just to use it. So there are four main characteristics of serverless. The first characteristics will be we don't want to manage the infrastructure. I don't care about the servers, I don't want to think about them, and I don't want to patch them. The second rule will be it needs to be highly available out of the box. So, we are building an application system, new Netflix, new Spotify, and so on. So we want to make sure that, it will be working all the time. So it needs to be highly available. If we would be using servers, we would need to spin up 2 servers in 2 separate data centers and so on. With serverless, we don't think about this because this is the job of the cloud to make sure that it's highly available out of the box. So with AWS, for those of you who don't know, AWS has got something which is called a region. A region is a place where AWS has got data centers. So in Europe, for example, there are 4 of those now. So Frankfurt, Ireland, London, and Paris. So when we are going to the cloud, we will, in Europe, we'll use one of those regions. And this region is not a single data center. This will be a collection of something which is called availability zone. And availability zone will be a collection of data centers. So the point here is if we will deploy the Lambda, this microservice, it will be automatically deployed across multiple data centers. So it's out of the box, highly available. The third rule, it needs to scale automatically. Again, the cloud is really popular because you can create auto-scaling groups. You can say, yeah, here's my server. I want to add new one whenever there is some things are happening. So when there is more users, add new servers and so on. But we need to do it with servers. With serverless, we don't do anything. We just deploy the, the business logic, and we are saying, yeah, do it. If there's more users, it needs to scale automatically. So for example, if there will be one user, what the cloud will do, it will spin up one instance of our business logic, of our function, of our microservice. If there will be 3 users who will be talking to our microservice in the same time, what the cloud will do will spin up 3 instances. But if there will be thousands of those users, what cloud will do will spin up just thousands of those instances. And the last rule of serverless is we don't want to pay for the idle time. So if we deploy our microservice, our logic in the cloud, but nobody is using it because we are not Netflix and nobody cares, or maybe just everybody are sleeping and they are just waiting, and in the morning they will start using it. In the meantime, when nobody's using this, we don't pay. Although it's ready. If somebody will wake up at 3 o'clock, at 3 a.m. and will check, okay, let's see the microservice, the cloud will spin up the service and it will do what we have implemented. So no users, no instances, so it's no paying. Okay, so where to use those serverless? There's a lot of different ways how we could use serverless. Very often they are being used to build backend applications. So we use, for example, a mobile application. We have got a front end, which will be Android, iOS front end, and we need to have some backend. We don't want to build this backend on servers because we will need to manage those. The backend will be Lambda, will be this serverless. But serverless is not only about functions. The functions, the Lambda will be the most popular, but it's not only the one. So in AWS there is about 10 or 15, depending how you count, serverless functions. So IoT, security, and many others. S3 as a storage service will be serverless because we don't care about the infrastructure as a user. So for example, very often Lambda is being used, like I said, to build a backend application. So very often to build a RESTful web services. So there's a service in AWS which is called API Gateway. So we will create an API, we'll define what is the address and so on, and we'll say whenever there is a request to this link, and this is a GET method, it should invoke this Lambda function. When there is another method, it should invoke this, and so on. So let's put it all together. Let's try to compare how we would build an application in an old style and in the serverless style. So old style, so with servers. So I need to have a data center because it needs to do, I need to have a place where I will set up my server. I will deploy my application, and then I have got the users, they can use it. I'm happy. But then I'm looking at this and I'm thinking, this is not highly available. If something will happen with the server, my application is not working. So I will find another data center, I will spin up another server, and then I will see, okay, I have got 2 endpoints, so it's not correct. So I will need to spin up a load balancer, and now my users are happy. Cool, it's done. But then, what if I will have got more users? I have got just 2 servers. So I will need to create an auto-scaling group. Okay, it will take 5 minutes in the cloud, but still I need to do it. Okay, we done it. But then what if there is nobody? Because this is the middle of night. There is nobody, everybody are sleeping. I will still have at least 2 servers. So I'm paying for this. And now let's compare this with serverless style. So we deploy our microservice to the Lambda. It will scale automatically. If we are not using it, we don't pay for this. It's, all those things which we did with servers before are being done here automatically. Lambda itself, like I said, is not being exposed as a HTTP endpoint, so we'll use also API Gateway to do this endpoint, and that's all. It's just much more easier to build microservices. Okay, guys, so let's try to do a short demo. We'll see how many demo we'll manage to do. How many of you have ever used AWS? Okay, about half of you. So, okay, so this is AWS. I will make it a bit bigger. So this is AWS console. So from this place, we have got access to services which are provided by AWS. And those things here are those Lego blocks. So for example, EC2 on here, this will be a server. Elastic Container Service will be about containers. So there is, about 100, 150 of those Lego blocks. But we are interested in Lambda because we want to create quickly a microservice. So I will go to the Lambda, and I have got some functions, but we will do everything from the scratch today. So I will create new function, new microservice. I will need to provide a name. So let's say I will say hello world Gdańsk. I will use the language, the environment in which I'm writing the code. So I will use Python 3.6, and the role will be something which I have created before. This is the permissions. I will use Lambda full access, so in short, this Lambda will have good access to everything. Okay, so let's create it, and let's go to the next step of the wizard. Okay, so we have got our microservices. If I will go down, I would see the business logic. And now it's not doing anything. So let's write something. Let's say this will be, the name will be an event in the input. So the input parameter was event, and let's say there was a name. And the response will be response hello name. And let's just return it. Return response. Okay, let's save it, and that's all. So now this microservice is just lying there in the cloud. We are not using it, so we are not paying for it. But now let's try to invoke it. There are different ways how we could invoke it. I could, invoke it using SDK of AWS. In this case, I would just invoke it using the test functionality on the top. So just from the browser to make it easier. So I will create a test case, my test case, and I will provide the input parameter name Tomek. I will save it, and I will just run it. And now what AWS did, it's invoked my microservice, it done something, I get hello Tomek, and it fall asleep again. So I will have got information that the duration was less than 1 millisecond and so on. So now again, if we are not using this, we are not paying for this. But this was microservice which we were invoking using SDK. So let's extend this to be a microservice which will be exposed as a RESTful web service. So it will have got HTTP endpoint. So let's modify this. And guys, of course, I will be modifying this code here. This is not the only option. Usually in the production, you won't be writing the code in the browser like this. Yeah. Okay, so the question was, what if this Lambda function rely on a lot of data lying in the memory, and so on. So Lambdas won't be for everything. So single execution can last up to 5 minutes, and you define how much memory have got Lambda. It can be from 120 megabytes to 3 gigabytes.
So the question is not how to run single Lambda, but if you have hundreds of thousands of Lambdas, and every Lambda rely on the same sophisticated structure in memory.
Okay, so let's wait with the question to the end, okay? Because I have got, if it's okay, because we have got a lot of things, and let's wait with the question, okay?
Okay.
Cool. So because it will a bit more complex question, so the answer will be a bit more complex. Okay, guys. So I have got also a piece of code which I will just use in this case. I will show you this now. Do you see the code, or should I make it bigger? Sorry. I know that you see it. The question is to the guys at the end. Guys, do you see the code? Okay, so guys, now I want to make a Lambda which will be exposed to the world, so as a RESTful web service. So I'm again expecting to get a name parameter, but this will be HTTP parameter. So there will be a link, question mark, and something. So this will be in the object query string parameter. So again, I'm preparing the response, hello, my name, and I'm just returning this as HTTP 200, so success. I'm saving it. And that's not all yet, because I need to tell the AWS that it should be exposed as a RESTful web service. So on the top, I will add a trigger, which is API gateway. So I will add it, and then I can configure it. So I will say, I want to create a new API, and I will do it open. So everybody will be able to access it. I don't want to validate credentials and so on, just to make it easier in this case. I'm adding the trigger, and I'm saving the changes. So now if I save it, what will happen if everything will, okay, it's working. API gateway provided me a link. So it's saying, okay, I've deployed, it's exposed as a RESTful web services. This is the endpoint on which you access your business logic. So if I will click on it, of course, this is quite random. We would probably use our private domain to access later, but at least for now, it's okay. So if I will open the link, I should get error. And the error is okay in this case, because my code was expecting to get the name parameter. If it's not there, it would just break because I didn't implement any this kind of logic. So in the link, I know that you don't want to see, but I'm adding the question mark, name Tomek. So I'm getting hello Tomek. If I would modify my business logic, let's modify this a bit to see that this is actually this one. Hello from Gdańsk. Let's save it. Okay, so our business logic is again implemented, deployed. I will refresh the link. Hello, Tomek from Gdańsk. So we managed to build this small, not fancy, but microservice with exposed as a RESTful web service just in 2-3 minutes. So guys, to make it a bit more interesting, so let's do another demo, but a bit more fancy. More complex demo. So more complex demo will be like this. We want to build an application which will expose with a RESTful web service. And in short, I will provide you with the link at the end. So you, with your mobile phone, you will be able to access the link. So you will access it, and in the parameters, you will provide a text, something in English and Polish, whatever. So again, I need to have API gateway. The request will go through API gateway, and then it will go to Lambda, which we will create, and it will be audio converter. What will be the purpose of this microservice? First of all, it needs to detect what language is the text, in which language is it. Was it English, Polish, French, and so on? To do it, it will use one of the Lego blocks in AWS, which is called comprehend. A comprehend analyze text. In our case, it will tell us, yeah, it's English, yeah, it's Polish, and so on. So at this stage, Lambda knows, okay, it has got the text, it has got the, what language what was used. So now we want to create an audio. So of course we'll use Poly. So we will call Poly and we'll say, here's the text. We want to convert it in a specific language voice, and Poly will provide us with the audio, with MP3. Then what we'll do, because we have got a lot of time, we can really build applications quite fast. We will save this information in DynamoDB. DynamoDB is NoSQL database, like Mongo, like Cassandra, NoSQL database. So we'll spin up a database, let's say in 30 seconds. So we want to log this information in the database. Then what we'll do, if in the request from your mobile phone you will provide a phone number of your phone number, then the Lambda will send you a link saying, guys, so the audio file will be saved on S3. S3 is a storage service. So for those of you who don't know, if you are using, for example, Dropbox outside of USA is using S3. So your data is on S3. So the data will be saved there, the file, and then it will send you a link to the file saying, click on it, and you will be able to listen to what you have written. Clear? Yes or no? Cool. So let's build it. So a bit more complex demo, so let's hope we'll do it in 5-10 minutes. So guys, what I will need to do first, I will go to S3 and I will create a bucket. I will create a bucket, so a place where I want to store my audio files, which I will generate later, okay? So this will be the first one. The second thing, I will go to DynamoDB and I will create a database where I want to store those information, okay? So those will be the first thing. So let's go back to AWS console and let's go to S3. So again, to one of the Lego blocks. So I will make it a bit bigger. So S3 is really easy because, in short, you are creating something which is called a bucket. A bucket where you store your information. I have got a lot of buckets. They are not important here, so I will create a new one. I will say I need to provide a name. So my bucket will be A, Tomek, 123, 123, 123. Okay, let's create it. And after 2-3 seconds, it should be there. Okay, we have got the bucket. Let's go inside of this. It's empty. This is serverless. So we didn't need to specify how big it will be. We didn't need to specify that it needs to be highly available. The data, if we'll save something here, will be spread across multiple data centers. Okay, so this is the place where we will be storing audio files. So let's stay with this. Let's leave it here because we'll go here later. Let's return to AWS console. And now in database, we'll use DynamoDB. There's a couple of different things like RDS, relational database, like Elasticache, this will be Redis, Memcache, Graph database, and so on. We want to have a NoSQL database, serverless NoSQL database. So I will go there, and I will create a database. In fact, what we are doing is we are creating a table. A table is a database. So we will need to name it. So let's say it will be records. And we need to provide, this is a NoSQL database. So we don't need to specify the whole schema, but we need to provide the primary key. And let's say primary key will be ID, like always, I guess. So let's create it, and that's that's all. In about 5-10 seconds, the database will be there. We'll be able to use it, and again, this will be serverless. So let's leave it here. Let's open a new tab. And now let's go to the Lambda to write our business logic. So I will go to the Lambda, and I will create a completely new function. I will say that the name is audio converter, and the runtime, again, for me, Python 3.6. And role, like before, I will use Lambda full access. And let's create it. Okay. So now about the business logic. So I don't want to risk. I'm not going to write everything by ourselves now because it would be just a bit risky. So I have prepared the code. I will show you this because it's quite interesting, I would say. It has got 100 lines. So guys, I will make it a bit bigger for everybody. Okay. Okay, so guys, this code should be invoked whenever there will be a request from HTTP request. We didn't do it yet, but assume it will be invoked. So what we are doing, first of all, we are checking in the request if there is a parameter called text. So like name, before now we want that there should be parameter with the name text. If yes, we will get this text, because this is the text which we want to convert into audio. And now what we are going to do, we will use Boto3. Boto3 is SDK from AWS to Python. That's why I'm using this, because we are coding in Python. So I'm saying create a client, comprehend client. Comprehend because we want to connect with this Lego block, with this service, to detect the language. That's why on this comprehend, I'm calling the method detect dominant language. I will provide the text, and I will get the language as the response. So, and here I will have got the language. What I will want to do next, I will want to call poly to create an audio file. The thing here is that the poly doesn't accept the language. It needs to get the voice. Because, it can be English, but there's about, 8 different voices. Male, female, child, and so on. So to do it, at the beginning, I specify a map. So whenever it's PL, Polish, use Maya voice. Whenever it's English, use Matthew, the German, Vicky, and so on. So I have, mapped those languages into the voices which are supported by the poly. Okay, so let's go back to the code. So now what I'm doing, I'm again calling Boto3. I'm creating the poly client, and I'm saying synthesize speech, so create an audio file. I'm providing the text, I'm saying create MP3 file. I'm saying in which voice it should be read, and that's all. So then I'm doing some Python things on the audio stream to create the audio file. And then what I'm doing, I want to save this audio file on S3. So I'm creating the client to S3. I need to which bucket to connect, where I want to store it. So I will create an environment variable with the name bucket. So we'll do it in a couple of seconds, but this bucket will be the name of my bucket which we have created. So Tomasz, something, something, something. And I'm saying upload the file, the MP3 file there. And I'm also saying make it public, so everybody could see it, everybody could listen to it. Okay, almost the last thing is connecting to DynamoDB. So now we also connecting to DynamoDB, which table, again, we have got another environment variable because we need to know to which database we want to connect. And we are saying put there a new item, new record, with those parameters. So ID, text, which was converted, language, voice, and a couple of different things. Then what I'm doing, this is maybe not the best practice, but for the demo purpose, I'm creating the response. And this will be a cool, nice HTML response with audio tag somewhere there, audio tag. So you will get the page with the player. So you can click and you can listen to the audio. What is at the end? If you have also provided your phone number as the parameter, then SNS will be used, so simple notification service, and it will try to publish a message to the phone number which you have provided, and the message will be the link to your file. If you didn't provide the text at the beginning, there will be a message, you need to provide a text, because I don't know what to do. And that's all. So I will just save it, and we need to modify two things. First of all, we have got two parameters. So there is a bucket and DB name. So bucket will be the name of my bucket of S3 bucket. So where I want to store those files, and DB name will be the name of my DynamoDB table. So name of the DynamoDB table was records. So records, and name of my bucket was Tomasz 123 123 123. Okay, let's save it. Two more things. I said it, but maybe in a different way. So when we are calling the lambda function, the single execution can last up to 5 minutes. So when we are calling the function, it can do something, but up to 5 minutes, not more. The default is 3 seconds. 3 seconds might be not enough to do all of those things which we have mentioned. So I will just increase it, let's say, for 30 seconds. It will take probably 5 seconds or something like this, but just in case, if it will be more, what AWS will do, it will kill it. So yeah, let's do it with 30 seconds. So that's all from the business logic in short. Let's save it. Okay, so what we are missing now, we want to expose it as a RESTful web service. So I will add an API gateway trigger, and I need to configure it. I don't want to create new one because I want to have my own domain name, because otherwise the link would be like this, and you would be, it would be hard for you to write it. So I have created already API which is using my domain name. It will be easier for you to test it. So I will use it. I'm saying, some default state, security, again, open. And I'm saying add, and I'm saying save. So now I will test it by myself, and then I will ask you to test it. So there is a, wait. Okay, so this is the link. So that's why I said that it's using my domain name, because it's using api.democloud. So in short, if you will try, if you could, okay, on your mobiles, try to access this link. So I don't know if it works, so I would prefer not to risk now. You mean now it make it shorter? I would prefer to leave it like this. Yeah, I know that's bit, yeah, but I don't want to risk it now. It's not too long, so I think you will manage to write it. You don't need to provide the phone, but if you will prefer, if you will do it, you will get the link with to audio file. But remember to add the country code, so +48, okay? Don't write anything bad, okay? Because I will later show you the DynamoDB table and so on, so we'll see the text. So I will be really grateful if you know, be good guys. I hope it will work. I didn't test it yet, so. I will test it here. If you are going to write something, it should be one word, because one word might be not enough to detect the language. Okay, so be a bit, more innovative. No, if you don't need to provide the phone. So guys, I have done it, in the browser. So I will write now something else. Wait. HTTPS. Yes, HTTPS. Okay. So this is demo from Gdańsk. Okay. So if I will do it. I got the response, I got the page.
This is demo from Gdansk.
And I got also the SMS. One more time. I know that not everybody will hear that. But
This is demo from Gdansk.
if I would go now to S3, the bucket where the files should be saved, it was empty. If I will refresh it, I created 2 files, so we'll see how many are there. So there's a lot of those. Cool. I'm paying for this, so feel free to do it. In DynamoDB, okay, guys. Now I will check what is in DynamoDB. I hope you are, good. So I click on the items. Okay, so there are, different records. I'm a bit afraid to go right because there's a text. But we see that, somebody tried to do it in French. I think this was the French. So even it's bad, I won't understand. So I guess, Bonjour, de Gdansk. Just, okay. This is my French, okay, so. Okay, and at the end we have got link. So hello from Aga, okay, something more innovative, and so on. I won't go through the rest, okay, because I'm too afraid. Yeah. So guys, if I would go to Lambda into monitoring, I would see how many people have executed this Lambda, and if everything went fine or no. So let's, okay, 167 times. Cool. So okay, great. 30 of those were errors. Okay, my Lambda might be not working because maybe you wrote, one word, it didn't work or something, okay? So 30 errors, but it's your fault, not mine, to be honest. So yeah. But okay, so we made it. So you see, in 10 minutes, we managed to build an application using serverless. Pretty cool, using artificial intelligence service, converting it, saving it into DynamoDB, into NoSQL database. Try to spin up a MongoDB in 30 seconds. Really, try. It will take more time. Okay, cool. So we have got only 30 minutes, so I won't go through the next demo, and we'll just go to the last part, to be honest. So the containers. So the containers, Docker containers, is another very popular topic among developers. So we want to build applications using containers with the Dockers. Guys, this is not a session about the containers Docker, so I won't go exactly what's the container and so on. Containers have got a lot of benefits and a lot and a lot of disadvantages. So, like everything. But in short, for people who have never played with containers, it means that we usually have got a server, maybe in the cloud, maybe not in the cloud, maybe a laptop, whatever, and we have got some containers. Let's say container A and container B. This could be our microservices, and we want to run it on the server. Why we want to run it there? Because we can use fully all the resources which we have got on the server. We can put all of those there. We are pretty sure that the container which we deployed on, which we created on our laptop, will work exactly like this in the cloud. And if we don't like the cloud, we can then take the container and go somewhere else. So those are more or less one of the benefits. But when we have got a single server, it's really easy to deploy the container. The problem is when we have got many servers, and this will be the reality. We have got a cluster of servers. In AWS, those would be EC2, a server in the cloud. And we have got to we have got containers, and we're thinking, okay, so where we should deploy it, where we have got a space. So, right? So if I want to deploy 2 A containers, I need to make sure that those 2 A containers are not on the single server, because it won't be highly available. So that's why very often we'll need to something like a container orchestration engine. So this will be a piece of software, another API, and we are talking with the orchestration engine. We are saying to this guy, this is the container, deploy it somewhere. And this is the container orchestration, objective, to find a place and to deploy it. To make sure that those containers are on separate servers, and so on. There is a couple of different things which need to be done by the orchestration. So for example, capacity management, so finding the space, auto-healing, self-healing, and service discovery. A lot of different things. This is not the topic exactly for this. So how we could do it in the cloud? One way is do it yourself. You can speed up a server. You can install one of the orchestration engines, Kubernetes, Swarm, or something else. There is a couple of those currently on the market. A different idea is to use a managed service, again, because we don't want to do everything by ourselves. Okay? So let's go with the managed service. And there will be three main ways. So one of the ways will be the Lego block, a service which is called EKS. This will be managed Kubernetes. So if somebody loves Kubernetes and he really is good in this, he can use this one. So it's up to you guys. Another case is ECS. This will be the engine, the orchestration engine from AWS. I would say easier to use than Kubernetes, but it's up to you guys. The last thing, and this is something on which we'll be talking now, is the Fargate. And let's go through each of those, in a more deep. So EKS, so the Kubernetes. So in short, what it will do, the orchestration engine will be spread across multiple availability zones. So across multiple data centers, in short. We will spin up a control plane, which is the place to which we are talking. We are talking to those servers, and we're saying those are the containers which we want to deploy somewhere. And below we have got those servers which are our clusters. So we deploy the containers here, and so on. ECS, it's exactly the same, but this time the orchestration engine, we don't see servers. We don't need to pay for them. It's a bit easier usually for users to start using this. But again, below we have got the cluster of servers on which we're deploying the cluster, the containers. The last thing, and this is the most important for this session, is Fargate. Fargate is about making everything easier, because we don't want to think about the servers. Because if we have got a cluster of servers which are managed by Kubernetes, ECS, or whatever else, we need to think about the servers. We need to speed up them. We need to make sure that we are using 100% of them because we are paying for those, and so on. Fargate is making this a bit easier because we are not spinning any servers. There's only a network. A network And when we will be saying to the Fargate, this is the container, deploy it somewhere, Fargate will find a place, will deploy the container, but we don't see a server. We don't pay for the server. We're paying only for the small amount of memory CPU which we actually using. It's just much more easier. So guys, let's do a small demo because it will be much more interesting. So what I want to do, I want to build a container. Who's using containers in your job, at university, whatever? Cool. A bit of you, not a lot. So I want to do this, the whole story from A to Z. We will spin up an environment where we will build a container, then we will deploy it into repository, then we'll build a cluster without the servers, and then we'll run the Docker. So everything. Okay, so let's go again to AWS console. Let's go to the main page. I will close the other tabs. And first of all, what I want to do, I will go to Cloud9. So I don't need Cloud9. I wouldn't need to have Cloud9, but Cloud9 is a pretty cool service, and I want to also show it to you. This is an environment in the cloud. So in fact, what it's doing, I will create a new environment. Let's say Gdańsk Env. I will just quickly go through it, and I will tell you what it is. So what Cloud9 will do, it will spin up a server to which we will have good access through the web browser. So we'll be able to access standard, in this case, for example, Linux shell, bash shell, okay? So we'll be treating this server as a place where we are building container. So everything is clean, I didn't do anything before, and so on. It will take about 1-2 minutes to do it, so let's return to AWS console. Like I said before, we want to build a container and then push it to the repository. So we need to have a repository. This could be a Docker hub or whatever else. In this case, I will use a Lego block from AWS. So I will go to the Elastic Container Service, and then I will find Fargate, and I will find a repository for containers. So I will make it a bit bigger. And on the left side, I have got repositories. I will click there, and I will create completely new repository. I will say this is Gdańsk repo. I will click next step, and that's all. So my repository is ready. So it's empty because I didn't push any containers there yet. I will do it in a couple of seconds. So if I will click on the view push commands, it's just telling me what are the standard Docker commands to build a container, to tag it, and to push it to, in this case, to this repository. Okay, so let's see if the Cloud9 is ready. It's ready. So guys, nothing fancy in this session, to be honest, because we'll be using the standard Linux shell. I will just make it a bit bigger so you could see it. Just give me 1 second. User settings, general. Okay. So guys, I will want to build a container here. So what I need also to do, I need to authenticate the Cloud9, so my environment with my repository. So it would be allowed to push Dockers into repository. So I will just execute the first command, which is just, authenticated the environment with the repository. I will just run it, and I should get login success. Cool. So now I'm okay. So I have prepared before an example of the Docker. So just give me 1 second. Okay, I will just execute 1 line of code. I know that you don't see it. Give me 1 second. Okay. I will execute this command. What this command did is it connected to S3 and it's downloaded my Docker project. So simple docker page.zip. So now if I have downloaded it, it's on the left side. So I see that there is this file. So guys, I will now just unzip the file, unzip simple, okay. If on the left side I have got now the folder, below there I have got a standard Docker file. So for people who are completely new with the Docker, this is the thing which we need. This is saying which operating system we are using, in this case Ubuntu. It's saying what needs to be installed on the image. So in this case Apache. Why? Because we want to create a simple Docker file which will have got some kind of web page. And this web page we would find in the source index PHP. So if I will open it, there's, for example, hello, this container is running in the cloud. I will just modify this and I will say hello from Gdańsk. I will save it. Okay, and I will close it. Okay, guys, so now I have got my project, which is a Docker project. So now I want to build it and push it to the repository. Now there won't be any AWS specific things. This is a standard things which we are doing with the containers. I would just go to the folder where we have got our Docker file. And now, because I never remember the comments, I will use those standard comments. So Docker build to build my project. What it will do, it will download some dependencies like Ubuntu and so on. Depending on what we are using, it can take 5 seconds, 5 minutes. But let's wait a couple of seconds and it should be done. The second comment which we'll do, it's about tagging. So we are saying we will be identifying this container by this tag. In this case, Gdańsk latest. So let's say 6, 7, step 9. Okay, done. So I will clear this. I will execute the tagging, done. And now I will just push this Docker to my repository. In this case, to the repository in AWS, ECR. So it's being pushed. It will take about 30 seconds, something like this. One thing here, the last command, this part, I will copy it because this is the information about where is my container and how we tag it. Because later when I will want to deploy it, I need to tell the cluster, the Fargate, the orchestration engine, where the container is being stored. And it's this part. It's saying, yeah, it's there. So I will just copy it and I will use it later. Okay, it's pushed. If I will refresh the page, I should see I should see that's loading. So let's pretend I will go to the next step. So guys, so now we are just 2 steps from having the container. Now, okay, we have got the container, latest, because we tag it like this. So before we will create a cluster and before we will deploy it, we need to create something which is called the task definition. This is information for AWS with information such as where is the container, how much memory it has got, how much CPU it has got, and so on. So I will go there to the task definition. It's like Docker definition. And I will create completely, I have got some of them, I will create a new one. I'm using Fargate. Next step. And I need to provide a name, of course. So I will say this is Gdańsk page. I won't describe all of the things because we don't have time, it's not important, but this one will be. So we are saying how much memory we want to allocate to those containers. Because we are going to pay for this, not for the server, because we don't see the server. So I will just select the smallest values, so 0.5 GB and quarter of CPU. And now I need to say which containers I want to add there to the task definition. So I will just click add container. I will call my container Apache, it's up to me. And here I will just provide the link, the ID with information, where is the container? It's there. It's tagged like this. Okay. I will also say that it's 0.5 GB of memory, and I will also expose port 80 to the world. So let's add it, let's create it, and that's all. So now we have got our information, where is our container and how much memory it has got. And now is the Fargate part. So this, everything is like, more or less standard thing. But now what I would do in an old style, I would spin up a servers. I would need to patch it, I would need to manage this, I would need to scale them, and so on. I don't want to do it. I want to focus on my business logic, which now is not on Lambda, now it's on containers. So I will go to the clusters, and I will create a new cluster. I have got some clusters here. It's not important. I will create a new one. and I'm saying, yeah, what kind of cluster do you want to create? Do you want to use servers, Linux, maybe Windows? Yeah. But in our case, no, we don't want to have servers because we don't have to pay for it and so on. Let's go with only networking. Let's go to the next step. Let's call our cluster. I will say Gdańsk cluster, and that's all created. And our cluster is done, so it's here. It's completely empty. Nothing is running in our cluster, and of course, it doesn't have any servers. So now I want to run here my container. So I will just go to the task tab, and I will click on Run New Task. Task will be a Docker which is deployed there. So task equals Docker in this case. I'm saying, yeah, deploy Fargate the task, which definition we have created Gdańsk page. So I want to have this container deployed there, the latest one. How many containers do you need? One, let's say. I don't have servers, but what I need to now to say is in which network I want it to be deployed. So this is the VPC. It's a bit different topic. VPC will be a network in the cloud. I will use the standard default network and standard default subnet. It means that my container will be deployed in a public subnet which will have got a public IP address, and I want this. So yeah, let's stay like this, and now let's run task. So now what we'll see in the task list that we have got a container. It's being in the status provisioning. What AWS is doing now is trying to find a server. Oh, a server. If it will find a server, when it will find a server, it will take this container, it will deploy it there, and after about 15 seconds, we should see the information that the container is running. So let's try to refresh the page to start spending. So we are almost there. So one more thing. This is just one installation, one deployment of container. If we would try to deploy the container from the services tab, we could do some other things. We could do auto-scaling of those containers. We could say, attach all of those containers to a single load balancer, so to have some kind of service discovery and things like this. We could do auto-healing and other things. So let's refresh it again. Still pending. Sometimes it takes a bit more. It's taking longer because we don't have a server. If we would have this server, benefits and disadvantages, then it would know exactly, okay, I will deploy it there. So it will go to the server, deploy, and after 2-3 seconds, we would have a container on the server. Now we don't want to have servers. That's why it's taking a bit longer time. There's also scheduled tasks. So for example, sometimes we know that the containers should run only from this time to this time on a specific day. So we could also schedule those things, saying, yeah, so on Monday at 5 p.m., take this container and run it, because it's doing some batch jobs or something like this. So we also, it's easier to manage those things. Any questions while we are waiting regarding the container? So what we are paying here is for the amount of the task definition. So for example, in this case, we have said that we want to have a task definition with half gigabyte and quarter of CPU. And this part has got its own pricing, okay? But the point here is that if you would spin up a server like this and you would put the container like this, you will be paying, of course, for this. And here you are paying for this part. I'm not 100% sure, but I would believe that. So the question was, do we pay for per hour, per seconds, and so on? I'm not 100% sure. I believe this is per seconds. Per minute? Okay. Close enough for me. Okay. So per minute. So if it's running 25 minutes and 26 seconds, we'll pay for 26 minutes. Okay. Yeah. I did something wrong and it won't work. So what AWS will do, AWS will patch operating system. It won't patch the Docker, the Apache, and so on. It's up to you. So if you know that, no, you don't. So you don't need to patch the operating system. But if you are installing some other thing, wait, just give me 1 second, okay? Because I have made a mistake, and I just would like to show you that it's actually working. So just give me 1 second. That's page 2. Okay. So I just need to try to run it again. I think I made a mistake in the definition. Okay, let's see. So the question was who is patching the Apache and so on. So it's not AWS. You are not responsible for patching the server, Windows, Linux, or whatever you have got there. But what kind of software you are using in the container, it's up to you. We won't be able to patch it because it's like probably everybody has had this situation in their life. You patch something and it breaks something, okay? So AWS won't touch what you have got in the container. AWS will patch the operating system, the Linux in this case. But if you know that you're using Apache version 1 and there's a new version, it's up to you to create, in short, a new definition of your container. Another question? Let's hope this time it will work. Yeah?
Okay, because you are showing the ECS, is Kubernetes supported?
Yeah, so this is a good question. So guys, I told you that there's EKS, there's ECS, and there is Fargate. Fargate in this part is just a substitute of ECS. So Fargate is still not supported for EKS. It will, it's announced. So
okay, but it's announced for this year?
I do not know. I believe that the date was not released. It's announced, it was announced last year at the reInvent, but I do not know the dates. Yeah. So it will be there, but do not know the date, to be honest. Yeah. Let's wait 2 more minutes. If it won't work, it means that I made a mistake somewhere. Sorry for that, for these guys, but yeah. Any other questions regarding container or also the serverless part, to be honest?
Yes, we have more time to another question about the serverless, about the Lambda, because you didn't mention anything about the security of the functions. Do you know any plans to optimize, to reduce the cold starts of the Lambda in the VPC?
Yeah, so cold start or security, which part?
It's from my point of view, it's both, because the cold, okay. If you have an API built in Lambda and you're using it inside the VPC, then cold start is a big issue.
So what is cold start? So for everybody, when we are calling a Lambda function, first time when it will be executed, it can take a bit more time, because in short, what AWS will do, it will need to spin up a container with the Lambda. So depending on how big the microservice is it 1 megabyte or 50 megabytes or whatever, depending on the language, is it Java, .NET, or maybe a light environment like Python or something like this, the cold start might be different. So it can be, depending on what we have got, you will notice the cold start, or sometimes you won't notice. If you are using the Lambda in VPC, the cold start will be bigger at the beginning, because it also the interface to VPC to be created and so on. So we are working on making it smaller. There are a list of guidelines which need to be done, which can be done to make it smaller, but it's up to you if you want to use it or not. So for example, one of the guidelines is if you are building your microservice, don't try to put all the third-party libraries which you might use in your life, but just use those which you are actually using. because it will make your code smaller, and then the code start will be shorter. No, I made some mistake. Sorry guys, I won't show you how that it's working, which is sad.
One more question regarding this, what you have just said. So any plans for Java 9 maybe, and making
guys, the number of environments is growing. So it's about 5 or 6 now. So it will get bigger depending on what are the requests. In short, about 80% or 90% of what we're doing is based on your guys' requirements. So if we see that customers want to have this and this language, we are adding this to the roadmap and we are trying to implement it. I won't be able to tell you, yes, this is on the roadmap and this will be added at this date. No, but if there are more and more users, it's affecting the roadmap because it should be we want to have something for you, not the other way. And question here because
Sorry, we have another question there. So you have a microphone already. Can you ask a question? Trying for a while.
Yes, I think it's my turn. I have 2 questions actually. One is, you know that there is a concurrency limit in the Lambda, and is it a good practice to handle for example, the web request on the Lambda, because there can be many Lambdas on your account, and it can affect the other Lambdas when you run a Lambda on your account. And is it a good practice to use the Docker container or to handle the request, or just use the Lambdas for the?
There's no one answer for this. Everything depends. So everything, every part of technology has got its own limitation, characteristics, and so on. With Lambda, there's a part about this scalability. So if you will create your new AWS account, you can have 1,000 of concurrent running Lambda in a region. If you want more, you can ask, you can raise a ticket and you will have got more. But let's say you're building a completely new application which will, and you want to process millions of events, let's say like this every second. Then there is a question if Lambda or maybe containers and so on. So everything depends what kind of applications you are doing and how much volume you will have got. Because what I would usually say is you may have a lot of users, but if you use Lambda, you have got API gateway, you can cache this on API gateway level. So even though you have got a lot of the requests from API gateway, it's caching the data and it's sending only subset of the request to Lambda. So then it's a bit solving your problem. So everything depends what you want exactly to achieve. If you are building a new Netflix or maybe a new smaller version and so on. So container versus serverless versus Lambda, it's like each of those has got different characteristics. With Docker, you can do whatever you want there. You can install whatever you want there. The container can run 5 hours, 5 months, and so on. With Lambda instance, 5 minutes. But on the other hand, it's just easier with Lambda. So very often what companies will do, this part will do with servers, this with containers, and this with Lambda. Maybe the backend of the application, let's do with containers, but maybe let's automate some data movement, some processing of data with Lambda. Because then it's okay. So usually what will be the good approach, to be honest, to mix those things. Because if we see that this block match and to solve our problems, let's just use it. Let's don't try to reinvent everything.
Mm-hmm. I have another question, and you say that there's a multi-easy support for the container orchestration in AWS. And can there be a support for the multi-region, like the DynamoDB? You know that there is a global table on the AWS, and for example, can there be a global regional support for the not Lambda, the container orchestration, for example?
Most of the services in AWS are regional. So we specify the regions. For example, here I'm in Ireland. Yeah. Some of the services, to make it clear for everybody, some of the services you can make global, like DynamoDB. So the database which we have created, we can say that it should be global. It should live in Ireland, in USA, and somewhere. And then AWS will synchronize the data. It's only for some of the services. So if you want to have it with Fargate, with orchestration engine, whatever, what you will do, you would spin up a orchestration engine here, and you would load balance the traffic using very often with DNS, on the DNS level, to be honest. But you would spin up two by yourself, I would say.
Okay. I have a question about price. So Lambda is for seconds, containers are for minutes, but who pays for data loading?
So depending on the situation, data loading is, what do you mean by data loading?
So whatever you need. If you run Lambda, you need to load some data, and you may load it from your service. But they don't have any influence on the speed of your service of loading. So do I pay for that time?
So if you load some data, if you are getting the data from outside somewhere, yeah, it's your Lambda is running. So it will be added to the time when the Lambda is running, and you will pay for the amount of the time. For the getting the data from somewhere, you won't be paying. The transfer in to the cloud is free. You'll be paying for transfer out. But the amount of the time to get this data, it will be added to that. So very often what you would probably want, if you can, of course it's not like always, if you know that your data is lying somewhere outside of the cloud, put it on S3, and then ask Lambda to call S3 to get this data, which might be just easier because then it's on our own private network, so the data will be able to get the data faster. But sometimes, of course, you can't do it. You need to call a third-party system, API or something, so then it's up to you to call them, and then we are calculating this time.
And very last question, so, and the last question? Okay, so, get the microphone.
I have a question about the pricing. Is there any free trial for Amazon AWS services like serverless functions?
Yeah, so there's, when you create an AWS account, there's something which is called a free tier. A free tier is something which for a lot of services, most of them to be honest, give you, you can use them for free. Depending on the service, it will be, something else. So let's see, free tier. So for example, if you would want to spin up a server in the cloud, you could spin up a small, You could spin up a small T2 micro server for free for 1 year. If you would be using, S3, for example, so the storage, it's 5 gigabytes. Okay, so depending on the service, this will be different. And usually this free tier lasts for 1 year. So you create an account, it's 1 year, you can use it. And after 1 year, it's up to you to create a new account or something. Some of the services have got the free tier longer. So for example, the Lambda free tier is forever, and every month again. So the free tier in Lambda is that you have got 1 million of execution, short one, 100 milliseconds for free. Every month, 1 million of those. If your Lambda is shorter than 100 milliseconds, but let's say 1 second, so 10 times like this, it's not 1 million, but it's 100,000, okay? So it's like, you see the math. So, and after a month, again. If you would be after this free tier, it would cost you, I think, 20 cents for another million. So that's why very often serverless is the way how startups are building applications, how you build